Hi, my name is Nathan Akapali, and today I'll be talking about my MDE project update. I'm taking the EX49D8 MDE class. So just to refresh your memory, EX498 is all about human-computer interaction, how the interfaces between humans and computers could be smoother, more intuitive, and just more efficient and better to use. Our project goal is to create a hand gesture recognition system. So we've all seen people might have a difficult time in advancing their presentation slides. Usually you have to be right next to your laptop or computer and you have to physically click on the arrow button on the keyboard. Um, and we instead want to create a wearable that can identify hand gestures and easily control presentations. And this way you don't have to buy external hardware like a remote control, or you don't have to always be next to your keyboard in order to continue on in your presentation. This wearable is having the advantages of being portable, lightweight, real time, and it's also non-invasive, meaning there's nothing that's going into your skin or into your body to detect these gestures. And it's important to note that there are a wide variety of applications that can be used with this hand gesture technology. So the steps that we've completed so far is achieving Wi-Fi communication between our wearable and the laptop. So we don't need a wired connection from our wearable to send data to for further processing on our laptop. We've also integrated our transducer with our VPU, and we've basically did that with a function generator with an external trigger, and I'll talk more about that soon. And we also obtained high test accuracy in classifying two basic gestures. Future work will require making the hardware into a more wearable wristband-like form factor. So think of like an Apple Watch type of form factor. We also need to create a data pre-processing algorithm to obtain higher test accuracy and advanced gestures. And we also want to ramp up the ESP32 hardware that we have, ramp it up to a higher output voltage using a MOSFET. And on the right, you can see some of our data signals corresponding to a particular gesture, and that is the data that we'll be using machine learning on to identify gestures. So to talk about a significant design decision, essentially we have a transducer, which is basically think of it like a speaker. And the transducer will emit a 25 kilohertz pulse once every second. We then have a receiver called a VPU to listen for the pulse and the after effects, so like the reflections from the emitted signal or emitted pulse. And this allows us to classify the gestures. And there are two main ways where we could have done this whole process. We could have either done synchronized transmitter and receiver or unsynchronized transmitter and receiver. So we ultimately went with a unsynchronized transmitter and receiver, and I'll just walk through why our thought process behind that. So a synchronized transmitter receiver, what that means is we send out the pulse, and then right after we have the receiver listening for the pulse and the after effects. So we know exactly when we sent out the pulse, and this means we'll have to do less data pre-processing when we give it to the machine learning models that we have. But the drawback of this is that it could interfere with some of the VPU data collection code, especially if that code is blocking. And that could be more of a mess and struggle than what we want. So instead we went with unsynchronized transmitter and receiver, which means that the receiver will be constantly listening and the transmitter can shoot its signal or its pulse out whenever it wants. There's no specific timing window where it has to do that. The benefit of this is we don't have to deal with the ESP32 internals or worry about dropping packets, and we can also just use the function generator without worrying about specific timing details. But we will have to do more complicated data pre-processing, especially frequency analysis, to identify when exactly the pulse actually occurred. So the major lesson that we learned from this project is understanding the dependencies within a project. So our project had a strong dependency on the hardware, and I was the only hardware person on the team. So maybe having and allocating more resources early on the hardware would give us more time to do data collection machine learning. Thank you.